As an airplane rolls down a runway to reach takeoff speed, it is accelerated by its jet engines. On one particular flight, one of the authors of this book measured the acceleration produced by the plane's jet engines. At figure 2.15 shows the measurements. You can see here 0 seconds, 5, 10 and 15 accelerations are recorded, and it is starting from 3 and it is almost 4.7 or 8, and it has the constant, almost the constant acceleration here in this range, and the average value is taken as 4.3 meter per second square. The acceleration, the takeoff acceleration, average acceleration over the time interval of 18.4 seconds. And what are we going to find? Assuming the average acceleration is 4.3, starting from the rest. So the initial x direction initial will be 0 meter per second, because the keyword is rest. So initial speed is 0. What is the airplane's takeoff velocity? In the x direction, final velocity we have to find. After 18.4 seconds. Then next, how far? So x we have to find x. The runway has the plane moved by that time it takes off. Okay, first we can find Vx final. So that we need the formula x is equal to x0 plus Vx0 times t plus half acceleration square. So this is the beginning position. The beginning position was 0 and the initial speed is 0 times t. Good morning. Plus half acceleration is 4.3 and times square. So 0 plus 0 times t is 0 plus 2.15 t square. This is the function of position. So x of t is equal to 2.15 t square. Now we can take the first derivative to find the velocity function. So dx by dt is equal to d by dt 2.15 t square. In the place of x we write this, and this will be 2 times 2.15 and t power 2 minus 1, so 4.3 t power 1, and this is the velocity function of time. Now we can substitute this time value 18.4. So 4.3 times 18.4 is equal to 79.12 meter per second. Thus we found the final velocity Vxf. X is the direction, one dimension to the positive x axis, and f is the final velocity 79.12 meter per second. And still we have the position function, that is x of t is equal to 2.15 t square. Using this, we can find the second question, that is how far down the runway has the plane moved by the time it takes off. So we have to find out how far. So x of t is equal to 2.15 t square. So the time is 18.4. At this time, what is the distance? 18.4 square. Answer is 727.9 meter. 727.9 meter distance is needed to take off the flight.